This is a video for Building Java Programs, Chapter 17, which is about binary trees. In this problem, we're going to be taking a look at trying to return the size of a binary tree here. So they give that the size of this tree is going to be 8. The size of, suppose we just had this one node here, the size would be 1. Or if I gave you this node here, the size would be 4. So what we need to do is we need to traverse the tree and count up how many elements you've got. So first let's take a look at some logistics. So int tree is this class that the book has constructed, which is a binary tree, and it has the overall root. So that's where the tree is going to start. And this is a class method, so it's not going to take a parameter. It's going to be similar to the size method or length method you'd have in arrays or strings or things like that. So in order to do this recursively, we actually need to create a helper function. So we're going to create another method size here that takes a int tree node that will be the current one we're working on. So in this example up here, it's going to start with this top node here, but then it's going to recursively call it on this node, and then on this node, and this node. So of course, with all recursive problems, you want to identify what your base cases and recursive cases are. So well, let's go ahead and start actually with calling from the main function to this helper function. So we're gonna call size. I got to return, and we're just gonna pass in that overall root. Then, we need a base case when we're done, and we're going to need a recursive. Okay, so how do we know when we're done? Well, the simplest thing is, you might think the simplest thing is when we've got one item, but that's actually not the simplest. The simplest is when we have no items, when it's actually null. So when we get down from here to here to here, eventually we're going to get down to here, the left tree, which is actually null. That is actually the simplest case. It's a common error for people to think, oh, well, it's when we don't have any children. But that's not as simple as it gets. The simplest possible case is when there's nothing whatsoever to do. So when null, return 0. That's the size when we've got nothing there. Okay. Otherwise, even when we've got to this single node here, what do we have to do? Well, we've got to add 1 for this node, and then we've got to add whatever is the size of the left and the right trees. For this case, it would just be 1, but let's pop up a level. Up here, it would be 1 for this node here, and then we'll have to add this node and this node. So you'll see 1 plus 1 plus 1. Up here, it would be 1 for this, plus whatever's on the left, plus whatever's on the right. So that will be 1 plus, it'll be 3 here, and it'll be 4 here. So let's write that out in pseudocode. 1 plus left tree size plus the right tree size. Okay, so now let's think whether this pseudocode is complete. Okay, so it's going to start by passing in this top node to the helper function. And the helper function is going to return 1 plus whatever this is plus whatever that is. So it's going to recurse, and it'll say, okay, what do we got here? Well, it's going to be 1 plus whatever it is here plus whatever it is here. We're going to recurse down here. So that's going to be 1 plus whatever is here and here. Those two are going to return 0. So it's just going to be 1 there. This guy down here is going to similarly return 1. So this one will be 1 plus 1 plus 1, so that's 3. And up here, this will be 1 plus these 3 plus down here. So this should work. We just have to write a little bit of code. So if top equals null, then return 0. Here, I'm gonna do it wrong just to show you what happens. Okay, so let's try returning just size of the top dot left. Let's try running that. Okay, so it didn't work. Let's see, did it even pass for any of the? It did actually pass for the case of the overall root being null. But here's a case where there's just one item here. We expected to return 1, we returned 0. And that's because it's only looking at the left children and not looking at what its current value is. So we could try solving that by adding 1 plus that. So it's never looking at the right case. So as suspected, the case when you don't have any right children, it's going to work. I think everything else here has right children. If there was a tree that was just left to left to left, like these three here, it would actually work. But we still have to add in the right. And now this should work. So what we have learned here, so with binary tree code, this is fairly typical that they're going to be asking you for a class method. So you're going to need a helper because you need some way to recurse. Second thing is it's standard recursion, so we know that we need to come up with our base case and our recursive cases. We know that we're always dealing with binary trees, and we're actually pretty much always going to have something that looks like this, where we have to recurse on the left and the right. In this case, we're trying to return a single number, so we're adding. But in other cases, we would need to maybe separately call a recursion on the left tree and the right tree. Yeah, oh, and the other thing was that the base case. The base case is not when you have a single node. The base case is when you have really nothing at all. You've recursed so far down that you're looking at null. It's always important to check that you've got that. So if you found this video helpful, please like and subscribe.